Okay, today we're going to talk about two things. We're basically looking at our introduction to polar coordinates. So we're going to look at kind of converting points from polar to rectangular and vice versa, as well as writing equations kind of in both of these, between these two forms. So, as we learn about polar coordinates, it's similar to what we do when we're graphing with rectangular, like you can think about that as your Cartesian coordinates, they're your x and y, where we have this origin point, but we're going to call that the pole. Okay, and then the ray is called the polar axis. When we locate a point P using two coordinates, we're now going to do what you see here. And we're going to have, rather than x and y, we're going to have a radius and some theta. So where r is a directional distance from the pole and theta is a measure of rotation from the polar axis. And think about how when it's positive, it's going counterclockwise, right? When it's negative, it's going clockwise, just like when we're graphing. Okay, so plot the given in polar coordinates and then give the three different representations for the point, such that, okay, we've got to, I'll look at the A, B, and C as we go through an example. So let's just talk about graphing them for a second. So on this first one, it's got a radius of 2. I gave you these graphs to kind of help you out. I would imagine each of these as kind of a unit of 1, so it's like 1, 2, 3, etc. So it's got a radius. If it has a radius of 2, it's saying, okay, that's a length of 2. And then it's saying it's going pi thirds. So if you look here, pi thirds is going to be going to the counterclockwise, right? And it's going all the way up to here. Okay, so it's kind of going along this line here. And then we're talking specifically though just about this point right here. That is going to be your point, we'll call it P. There is a way to do it when you can do the angle and then go out 2 units. That's another option. However, I like to usually graph the radius first. Okay, now that we have found that, let's talk about these other ones. So, here we had a positive radius of 2, and our theta was pi thirds. So let's talk about if r was a negative radius. If r was a negative radius, rather than being positive 2, it would be negative 2. So you can think about that on your graph as starting negative 2 to the left, but we still want to end up here where that reference angle, right, was pi thirds. So in order to do that, we're going to go ahead, so this is pi thirds, we're going to end up here, at this point. In order to do that, think about, okay, well, I went how many degrees from our original radius of negative 2? Well, I went a half rotation, right? So that's pi plus another thirds. So I went 4 pi thirds from that initial negative 2. Okay. If our radius is positive, but the angle is negative, so you're still saying, okay, we're starting here at positive 2, but this time if I go clockwise, how far do I have to go to get to this reference angle? And in this case, that would be 5 pi thirds. Okay, and then last but not least, saying keep your radius positive, but basically pi thirds is the same as what if we go larger than 2 pi? So if you think about pi thirds beyond 2 pi, that is 7 pi thirds. Okay, let's look at the next one. On this next one, if we think about still this being like radius 1, 2, 3, 4, this one has a radius of 7 halves. So you can think about that as being a radius of 3.5. And then we're taking this and we're rotating it negative pi 6. So we're going to go a full rotation, right? That's negative pi 12ths. And then an additional 6th. So this is like a half. So let me just see. So this is a half, right? This is then the one that comes 1, 2, 3, 4, 5. Okay, so then this is going to just be a 6th. So we're going to come all the way down to here. And then your ending point that we're speaking about is this point right here. Okay, so now let's talk about what these are equivalent to. So if it was negative, our radius was negative, we have negative 7/2. But I wanted to go a positive distance. So this time I'd start over here at negative 7/2. But I want to go a positive distance to get over here. So I would go in that case 5 pi 6, right? Because remember this reference angle here is pi 6. In this case, negative pi 6, right? Okay, so let's go to the next one. If I start with a positive radius of 7/2, but I want to have now a negative angle, the easiest thing would be just to call it negative pi 6. I mean, you could do the negative 13 pi 6, right? That'd be equivalent, but negative pi 6. Okay, I could do 7/2, and if I wanted a positive angle, think about taking negative pi 6, and if I'm going, I want something above 2 pi, but also positive. So think about the 5 pi, okay, so negative pi 6, if I add 2 pi, think about that as 12 over 6, that would give me 11 pi 6, but that's still not bigger than 2 pi, right? So if I add another pi, 11 pi 6, plus another 2 pi, that's going to give me 23 pi 6. Is something bigger but equivalent to. Okay, last but not least, this one, we're now going to less than -1 to -2, -3, -4. So it's got a radius of -4. And then this time, I'm rotating counterclockwise, right? Because it's positive. So I'm going to go a whole, and then 5 pi 4. So I'm going to go a whole pi, which is 4 pi 4ths. And then this one's actually a little bit tricky because I think it's between 1, 2, 3, 1, 2, 3. I think it's this line right here. So we're going to go all the way to here. So then we're talking about this point right here. Okay, so now let's talk about what this is equivalent to. So A is we're going to have a negative radius, but a positive angle between 0 and 2 pi. So let's just leave that as it is, 5 pi 4ths. Okay, next we're going to have a positive radius, so positive 4. We want a negative angle. So this time, think about if I started at positive 4, how could I do a negative angle but end up here with this reference angle of pi 4ths? So it's one less than like a whole rotation of pi 4ths, so it's going to be 7 pi 4ths, right? And then it is negative, the direction we went. Last but not least, if I take that positive 4, and I think about this being a positive direction now, right? So I start at positive 4, and I want to talk about, hey, if I went clockwise, I just have to go pi 4ths, right? But this time I want it to be greater than 2 pi, so if I go all the way around the circle and then pi 4ths again, that would be equivalent to 9 pi 4ths. Okay, so that's graphing polar coordinates. Let's now talk about how we convert between rectangular and polar. So let's draw a right triangle over here on the right. So this is our pole, right? And this is the point we're talking about. If we want to think about this as rectangular, then this is your x distance and this is your y. And this makes a right angle. Given this point, though, this is technically my theta and this is my radius. So if we want to talk about expressing x in terms of r and theta, then what we need to go ahead and do is think about our trig functions, right? So let's talk about sine. So technically here, sine of theta is equal to the opposite, which is y, over the hypotenuse, which is r. If you think about solving that for y, we can times both sides by r, right? So y equals r times sine of theta. Similarly, I could do the same thing with x, but this time I would use cosine, right? Cosine equals x over r, multiply both sides by r, and x equals r cosine of theta. These two kind of ideas, which we already knew that x was cosine theta and y was sine theta, the only thing we're adding in is the radius because we're not necessarily on a unit circle now. Okay, to find r, use the Pythagorean theorem. So we would know our two side lengths are x squared plus y squared, and the hypotenuse is r, so it equals r squared. That equation will also be useful. And then finally, tangent of theta equals the y over x. So that will help you as you're trying to find like theta, for example. This would imply that theta equals arctan, right, of y over x, etc. Okay, so let's go ahead and convert. Right now these are polar and we want to put them into rectangular. So just as you're getting started here, I would probably write things like, hey, this means that your radius is 5. You probably could just label it below, right? This is meaning that the radius is 5 and your theta is 7 pi fourths. So if we want to find x, remember that x just equals r cosine of theta. So we're going to plug in 5 for r, and then we're saying cosine of 7 pi fourths. This is super handy, right, when we made that little table and we kind of had our reference things. So if you need to, remember we did like sine, cosine, right? You did like 0, pi 6, etc., etc. And then we like labeled this as 0, 1/2, ... right? And then like 1 square root of 3 over 2. I would definitely have one of those handy, as well as remember that all students take calculus, so you know the signs in each of those. Okay, so if I look at cosine of 7 pi fourths, that's going to have a reference of pi fourths. So cosine at pi fourths is square root of 2 over 2. But since we are here in the fourth quadrant, cosine is positive, so this is going to be times the square root of 2 over 2. So this will equal positive 5 square roots of 2 over 2. Then for y, we do the same thing. Y equals r sine theta. And r is 5, and sine is 7 pi fourths of 7 pi, sine of 7 pi fourths, sorry. So 5. Pi fourths is also sine of pi fourths as a reference angle, square root of 2 over 2. But in the fourth quadrant, sine is negative, so it's going to be times the negative square root of 2 over 2. So we get negative 5 square roots of 2 over 2. So if you wanted to actually write that as a point, then you would say, oh, hey, this is 5 square roots of 2 over 2, comma negative 5 square roots of 2 over 2. Okay, let's go to the next one. So I'll just do it in different colors so we can kind of keep things straight. So this is saying, hey, my radius is negative here, and my theta is the 5 pi fourths. So x equals my radius of negative 4 times cosine of 5 pi, 6. I think I said fourths before. So we're doing negative. Cosine of 5 pi 6 has a reference angle of pi 6, which cosine at pi 6 is square root of 3 over 2. However, since we're in the second quadrant, sine is positive, that means cosine is negative. So this would be equivalent to 4 square roots of 3 over 2. It does become positive because you have a negative times a negative there. And we can simplify that. 4 divided by 2 is just 2 square roots of 3. Okay. Y equals 4 times sine of 5 pi 6. So negative 4 times sine, and then pi 6 is my reference angle, so it's a half. We're in the second quadrant. Sine is positive, so we are multiplying times a half. So we do get negative 4 times a half is negative 2. Okay, so this point is going to be square root of 2 square roots of 3, sorry, comma negative 2. Okay, on the next one here, same idea. Your r is negative 20 and your theta is 3 pi. So x equals negative 20 cosine of 3 pi. So negative 20 cosine at 3 pi is equivalent to negative 1. So we get a positive 20. Y equals negative 20 sine of 3 pi. And then negative 20 sine at 3 pi is 0. So we get 0. So this is the point 20, 0. Okay. Let's now convert from rectangular into polar. So this is saying, hey, this is x and this is y. So we need to find r and we need to find theta. To find r, we'd have x squared plus y squared equals r squared. Which if you wanted like a little shortcut there, you could definitely think about this as r equals the square root of x squared plus y squared, right? So here we're going to have r equals the square root of 7 squared plus negative 7 squared. So we get square root of 49 plus 49. So the square root, actually I think I'll write it that way. I think it may help out. 49 plus 49. So square root of 98. Which if you wanted to simplify that, right, you could break that down and you'd have 49 times 2. So 49 breaks down to 7 and 7, so you can pull a 7 out and you'd be left with the square root of 2 inside. Although they often say you do not have to kind of simplify things, so if you want to leave it as a square root of 98, that'd be fine too. Okay, now let's talk about theta. Theta comes from, your tangent of theta equals y over x, right? So remember we said, okay, that means that the tangent inverse of y over x will give you theta. So tangent, in this case, our arctangent or tangent inverse of your y value is negative 7 over 3 equals, if you wanted to, you could definitely write that as tangent of negative 1, right? Tangent inverse of negative 1 equals, in this case, negative pi fourths. And you can have that from that chart that you made above, or you may just know that, or you can use your calculator, right? However, oftentimes, so in this case, I should say the radius is 7 square root of 2, and then I could say negative pi fourths. However, they often will say you can also use a positive, like use between 0 and 2 pi. So you should recognize that negative pi fourths is equivalent to 7 pi fourths. So either of these answers would be acceptable. Okay, let's now look at the next one. On this next one, we're trying to look for the radius again, right? So let's start by finding that. So if I square the square root of 3 over 4 plus negative 1/4 squared, and I set it equal to r squared, here I'd get 3 over 16 plus 1 over 16, so equals r squared. So I'd have 4 over 16 equals r squared. Take the square root of both sides, and you end up with r equals the square root of 4 is 2, and the square root of 16 is 4. So r equals a half. Okay. Now if I do arctangent, or tangent inverse of y, I'm going to have negative 1/4. I'm going to write it like this for a second. Divided by square root of 3 over 4. And you want to take a little moment. I mean, while you can't type that in your calculator, I would just think about that for a second, like negative 1/4 divided by square root of 3 over 4. Okay, well I can do my invert and multiply. The 4's cancel, I get negative 1 over the square root of 3. That should be one that you do recognize. However, if it's given you some heartache, right, use your handy dandy calculator because you can. And in this case, you would end up with In this case, we end up with negative pi sixth. So you could write your answer here as 1/2, negative pi sixth, or we may run into that problem like we had before, that hey, it should be between 0 and 2 pi, so equivalent that in 2 pi would be 11 pi sixth. Okay, looking at the next one, once again, let's find r, so we're going to do like our 12 squared plus negative 9 squared equals r squared. So we end up getting 225 equals r squared. Take the square root, and r equals 15. Okay, so now I do my tangent inverse of negative 9 over 12. You may even simplify that, and you're like, well, that's arctangent or tangent inverse of negative 3 over 4. However, even just with that part, you're probably like, well, I don't recognize that as one of the ones like for my table. Like, it's not a common one, like pi sixths, pi fourths, pi halves, pi thirds, right? So that you may have to leave as is. Our theta here, though, be a little bit careful, right? If you think about plotting this originally, we are here in the fourth quadrant. And I'm sorry, all these end up being the fourth quadrant, but the same idea applies no matter what quadrant we're in. And when I do my tangent inverse, it will give me something Actually, it will give you something here that is in that quadrant. So we can just leave it as is, as arctan of negative 3/4. Okay, so this one would be 15, arctan of negative 3/4. Okay, I do want to make a little side comment because this will come into play in the homework, and I thought I had changed this example to make it, but I did not. So with that in mind, let's take a little look together. So let's say you had something different. So like, let's say we had ended up with positive 3/4, but our angle had actually been over here, like in the third quadrant. So when you plug in arctan of 3/4, we'll get some angle, reference angle as first quadrant. So remember to write the angle that goes all the way over here to this quadrant. It would be like pi plus whatever you get with that arctan. So that may also apply that, like, hey, if you want something with, in the other quadrant, you may have to do like pi minus that. So just a heads up there, you've been warned.